This is a highly efficient wind turbine. Here are some additional images to give you a better concept of it. Here is how it works. A 13-mile-per-hour wind enters the front cowling. It then gets diffused and augmented by the center cone and forced towards the turbine blades. With this, the wind compresses and velocity increases to 21 miles per hour. Bett's law states that you cannot extract more than 59.3% of the energy in the wind. Otherwise, the wind will bottleneck and find another way around. That means 59.3% of the cowling's front surface is the cone, and 40.7% must be open for the wind to flow through. The average wind speed in the USA is 13 miles per hour. The wind must increase to 21 miles per hour to flow through the 40.7% of the cowling, which is a 59.3% increase in velocity. Once the wind has flowed through and turned the turbine, which extracts 59.3% of the energy in the wind is returned to 13 miles per hour. Wind, by the way, is energy mixed in the air in the form of movement. If there is no air movement, there is no energy in it. On the back side of the front cowling is another cowling with the same inside diameter and a larger outside diameter, which is in the form of a hollow venturi funnel. So wind on the outside of the cowling, still traveling at 13 miles per hour, is directed inside by means of a funnel to increase the velocity to 21 miles per hour, which also siphons wind into the front cowling at 21 miles per hour. The 13 mile per hour wind behind the turbine wheel is swept up to 21 miles per hour also. The wind inside the rear cowling is released in a reverse cone and decompresses back to 13 miles per hour, which causes the venturi effect, or siphon. The venturi on the back also eliminates any turbulence inside, which would otherwise occur to some degree. Plus, there is no low-pressure pocket on the back side. Wind coming in the front cowling leaves the rear cowling at the same speed and does not disrupt the outside wind. Velocity is to the third power. So a 100% increase yields 8 times the energy. We will get about 150%, which should generate 12 times the energy. Along with this, there are compounding effects built into this wind turbine, all of which increase the torque, which of course is the bottom line. There are airfoils on every turbine blade to take advantage of the increased velocity, and the turbine blades are located at the outside diameter to maximize the leverage to the axis point. On the outside of the turbine wheel, there is a built-in weighted flywheel that evens out gusting wind speeds and maintains momentum. Also included is a torque converter used to regulate the RPMs to 1800, the best generating speed. Another truly amazing fact is that there is very little, if any, low-pressure pocket on the back side, which has always been a huge factor in fluid dynamics. Simply said, the faster you go, the harder it is to go faster. That means the faster you go, the stronger the low-pressure pocket gets, which is actually a vacuum. This is one of the effects that will set this wind turbine apart from the rest.